linear and non-linear systems. Linear system is basically a system that follows superposition theorem. The superposition theorem contains two things. One is law of additivity and law of homogeneity. So if we say superposition theorem, to satisfy the superposition theorem, it has to have law of additivity, it has to satisfy law of additivity, and law of homogeneity. Okay, now let's see what are these, and also we will see an example at the end. Okay, now first of all, if I take the system, first I'm going to look at law of additivity. Let's mention that here. So first I'm checking at the law of additivity. Okay, so in order to satisfy law of additivity, let's see what has to happen. So let's say this is our system, and we have the output, the input, okay, this is our system. Okay, and then what we do is we take two inputs, x1 of t, x2 of t, and the output from this one is y1 of t, y2 of t. And for the first step, what we do is we take these two outputs right here and then do the addition. So we sum them, and by summing them we will end up having a result of y1 of t plus y2 of t. And this has to be the exact same thing when we do the when we add x1 of t and x2 of t. If we add x1 of t and x2 of t and get the same results, then this is satisfying law of additivity. So what you do is you take these two inputs and sum them directly. Okay, and when you sum them, we are summing x1 of t plus x2 of t, and this is our system. So after summing, it goes through the system. Now what will happen is whatever the t will be replaced with whatever the function we have. It's like we will see an example, so you will see that clearly in an example. But for now, let's say we feed it to the system and we deriving y prime of t. This y prime of t may or may not be equal to y1 of t plus y2 of t. If it's equal to y1 of t plus y2 of t, then it is satisfying the law of additivity. Okay, this is satisfying the this is satisfying the law of additivity. And if it's not equal to y1 of t plus y2 of t, and this is not satisfying the law of additivity. So when you're checking whether a system is linear or not, and when you're checking law of additivity, and if it's not satisfy law of additivity, you don't have to check the law of homogeneity. You can stop right there and say it's non-linear. But in case if it's satisfied, then you have to go to the next step and prove the law of homogeneity as well. So once you prove both of them, you can say this system is linear. So next thing we are going to see is how the law of homogeneity works. That is exactly similar to this, but instead of addition we do the multiplication. So we multiply by a constant. So for that one, what we do is let's say 2 law of homogeneity. For this one, only one output is enough, one input and one output is enough. So let's say we have x of t, and then we feed this one to the system, and we get y of t. And what we do is this y of t, but when we are doing example on the, we do the multiplication of the output right away, but here we are showing the we have an output and we are multiplying this one by a constant k, and when you multiply this one with a constant k, you will end up getting k y of t. Okay, so when you do the same thing for the x of t, so now what you do is you multiply the input by a constant and you get kx of t, and it goes through the system, and the new output y prime of t. If this y prime of t may or may not be equal to ky of t. If it's equal, it satisfies the law of homogeneity. If it's not equal, it is not linear, it is not satisfying, therefore this is not a linear system. So there are two possibilities. Now let's look at an example. So this is the explanation of what is the law of additivity and homogeneity. Okay, law of additivity is basically when you add the output and when you add the input, it should be equal unto the output. Like when you add the input directly and feed it to the system, it should be exactly the exactly equivalent to adding the output alone. Okay, so similar to this here, if you multiply the output by a constant, that should be equal to when you multiply input by a constant as well, by the same constant as well. So if it's equal, then that's linear system. If it's not equal, then that's non-linear system. So let's look at an example so you will see, you will understand it better. Let's say we have a function y of t that's equal to x of sine t. Okay, so this is a function we have. First we are checking law of additivity. So for law of additivity, we need to take this output and put it as two of them. For law of additivity, we need two input to output. So y1 of t, x1 of sine t, and y2 of t, x2 of sine t. For the first step, what we do is we just add the outputs directly. So y1 of t plus y2 of t, and that's going to be automatically add this one as well, which is x1 of sine t plus x2 of sine t. Okay, and this is the first step. Then what we do is we do the same thing for the inputs. So here our input is x1 of t plus x2 of t, and we feed this one to the system, and the system convert whatever the time into a sine t. So these times will be replaced with sine t, so we will end up getting x1 of sine t, x1 of sine t plus x2 of sine t. And if you compare these two are same. Okay, so therefore it satisfies law of additivity. So this is satisfying law of additivity. So we cannot confirm linear yet. We had to, if it satisfies law of additivity, we have to go and check law of homogeneity. Then only it satisfies the superposition theorem. So now what I do is I go to the second step. I check for law of homogeneity. To check the law of homogeneity, what do I do is I multiply the output by a constant. So our output is y of t. I multiply that one a constant. For this one, we don't need two output and two input. We just need just one of them. So I just use the y of t directly. Multiply the output by k. That will end up multiplying the x sine of t also by k as well. X of sine t by k as well. Then what you do is you take your input. Our input is x of t, so k times x of t, and feed it to a system, and the system changes whatever the time into sine t. So we will okay, this is kx of t. Okay, so the system will change whatever the time into sine t. So we are going to end up having, after feeding the system, we are going to end up having kx sine t. And if you compare these two are equal, therefore this one also satisfies law of homogeneity, therefore this system is linear. Okay, that's how we use the superposition to find a system is linear or not. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.